Find the area of the shaded region in figure 12.19 if PQ equal to 24 and PR equal to 7. So we mark this. PQ is 24 and the PR is 7. We start first with RQ. We can see that RQ is the diameter. So let's write that. RQ is diameter because it passes through the center. If RQ is a diameter, that means this angle will be 90. Angle RPQ equal to 90 because it becomes an angle in the semicircle. Angle in semicircle is 90. Now if RPQ is 90, we can use Pythagoras theorem in the triangle RPQ. We will use Pythagoras theorem. In this we have to see which is the hypotenuse. We know the hypotenuse is opposite the 90 degrees and RQ is the hypotenuse. So we'll write RQ square equal to RP square plus PQ square. RQ we do not know. RP is 7 square plus 24 square. So RQ square equal to 49 plus 576. So RQ square equal to 625 and RQ equal to under root of 625, which is 25 centimeters. So RQ is 25 centimeters and RQ is diameter. So diameter equal to 25 centimeter. This is one part of the sum. Now for the second part of the sum, we will find the area of the semicircle. So here is the semicircle. So we find area of semicircle. Now semicircle is half the circle. So it will be pi r square, which is full circle, divided by 2. So 1 by 2. We know the pi is 22 by 7 and the radius will be 25 by 2 because we know our diameter is 25, so radius will be 25 by 2, r square, 25 by 2. So this will be the area of the semicircle. On working, you will get the answer 6875 over 28 centimeter square is area of semicircle. Now to find the area of the shaded region, we have to do semicircle minus this triangle. We have to remove the area of this triangle. So from there we subtract the area of this triangle, we will get the area of the shaded region. So in the next step, now we are going to find the area of this triangle because we need to subtract it from the semicircle. And if you see this triangle, it's a right angle triangle because we know this was 90. This angle was 90. And area of a right angle triangle is quite easy, half base into height. So now we find the area of this triangle. Area of RPQ will be half base into height. In a right angle triangle, here we take the base as PR and the height is PQ because the angle between them is 90. So that is half, and we know it will be 24 into 7. And the area comes 84 centimeter square. Now to find the area of the shaded region, this region, we have to do area of the semicircle minus area of the triangle. So next step is to find area of shaded region, which is equal to area of semicircle minus area of triangle. That will be 6875 over 28. Area of semicircle minus triangle is 84. If we take the LCM is 28, it becomes 6875 minus 2352, and this works out as 4523 over 28 centimeter square. That will be the area of the shaded region. That is this area, the area of the yellow part. So we did that area of the semicircle minus area of triangle. Find the area of the shaded region in the figure if the radii of the two concentric circles with center O are 7 centimeters and 14 centimeters respectively, and angle AOC equal to 40 degrees. So in the sum, for the first step, we will find the area of the sector AOC, this entire sector. So step 1, we'll find area of sector AOC, and area of sector is theta by 360 pi r square. So theta in this case is given as 40. This angle was given as 40. The radius they said was OA was 14. So this radius is 14. So radius equal to 14. So area of sector AOC equal to 40 theta over 360. I'll keep the pi here. R square is 14 square. In the next step, we'll find the area of this little sector, that is BOD. So we have area of sector BOD, again theta 360 pi r square. Now in this case the theta is the same, and that is 40. This will be 40, and the radius here they said is 7. So for the other sector we take theta 40 and the radius here is 7. So let's put the values. So we have 40 over 360, the pi we keep here r square. I'm not going to calculate the values, but see how we can do it in an easier manner. So now we got to find the area of the shaded region. This is the shaded region, the area of which we need to find out. To find the area of the shaded region, this yellow area, from this yellow area we need to subtract this area, which is the green one. This area has to be subtracted, and what remains, once we subtract this area, whatever remains is this blue area. So area of shaded region equal to this yellow area minus the green one. Let me repeat that again for you. So we have this yellow area, this entire, this yellow, and from there we will subtract this green area. On subtracting, what remains is the blue area, which means now the yellow area we know is 40 pi into 14 square over 360. minus the green, which is 40 pi 7 square over 360. Now I can take common out. If you notice, I can take 40 pi over 360 common out. What will remain here is 14 square minus 7 square. So we said the area of the shaded region will be 40, 360 pi. We took common out. What remain inside is 14 square minus 7 square. So we put the values. 40, 360 pi is 22 over 7. 14 square, 196 minus 49. So I cancel this. This will come 9. So 1 by 9 into 22 over 7 into 147. This 2 can be cancelled, so you get 21 here. Here again you can reduce. This will be 3 and this will be 7. And when you work this out, you get 154 over 3 centimeter square. So the area of this region, that is a shaded region, is 154 over 3 centimeter square. And to go over the sum again, how did we find out this area of the shaded region? In the first step, we found this area, and from there then we subtracted the green area. And once we subtracted the green area, what remained behind is the blue area of the shaded region. Find the area of the shaded region in the figure if ABCD is a square of side 14 and APD and BPC are semicircles. So this blue region we need to find, and for which first we will find the area of the entire square. Area of the square. So to find area of ABCD, which is a square, and you know the formula is side into side, and the side here is 14 centimeters. This is 14 centimeter, here 14, all sides are equal, so it is 14 into 14 will be the area of the square, which is 196 centimeter square. So from this entire area, we need then to find the blue. We found this entire area. This entire square is made up of 2 semicircles. So in step 2, we will find area of 2 semicircles. So we know area of one semicircle is pi r squared divided by 2. But here we have 2 semicircles. So 2 into pi r squared divided by 2. And the 2 will cancel. So the area of the 2 semicircles is pi r square. Pi 22 by 7. Now what is the radius of the semicircle? We know this entire is 14. The diameter is 14. So here diameter is 14. Therefore radius is equal to 7. So here we are going to put 7 square. 7 into 7. So I'll cancel this. And we have 22 into 7 is area of 2 semicircles, which is 154 centimeter square. Now to find the area of the shaded region, you'll definitely agree this shaded region, which we need to find, this shaded region plus this shaded region. To find this blue area, we have to do area of this full square minus the 2 semicircles. So now to find area of shaded region will be area, this yellow area which is a square, minus the semicircle. circles. Now area of the square we found as 196. So we'll write this is area of square minus area of semicircles, and this is 196 minus this is 154, which is equal to 42 centimeter square. So to go over the sum, first we found this entire area of this whole square. From this we then subtracted the two semicircles. This semicircle and the area of this semicircle was subtracted. After we subtracted that, what was left is this shaded region. That is how we found the area of the shaded region, square minus two semicircles. Find the area of the shaded region in figure 12.22, where a circular arc of radius 6 centimeters has been drawn with vertex O of an equilateral triangle OAB of side 12 centimeters as center. So we got to find the area of the shaded region. And if you see, the shaded region can be divided into two areas. One is the area, one is this equilateral triangle. So in the first step we'll find the area of the triangle OAB. Now triangle OAB is equilateral. They've given this to us. And the side of this triangle, the side which is OA or OB or AB, is 12 centimeters, which is also been given to us. Therefore, area of OAB will be the formula of equilateral triangle area, √3 by 4 side square. So that will be √3 by 4, and the side is 12. So 12 into 12. We cancel this, this becomes 3. And now when you multiply, you will get 36 √3 is area of triangle OAB. Now we also have to find the area of this major sector and then add both of them. So we now next we're going to find the area of this major sector. So this sector we will just write it as P, maybe Q and R. So in step 2 we are going to find the area of sector PQR. And area of sector, you know the formula, theta 360 pi r square. So what is the theta for this angle, for this sector? We know this angle here is 60. Why is this angle 60? Because it is an equilateral triangle. All the angles of an equilateral triangle are 60. Therefore, the angle on the other side, which is the angle of this sector, will be 360 minus 60, and that would be 300. So for this sector, the theta is 300, and the radius, we know it was given to us, this is the radius which was given to us as 6. So the radius is 6. If we go ahead and substitute, so the area of the sector, theta we know is 300. You know how we got 300? 360. The pi 22 by 7, and the r is 6. So 6 into 6. This would be the area of the sector. So we will cancel this out. Then we have 6 ones are 6 6 are. This 2 cancels. So we have 30 into 22 over 7. So total area equal to the green, which is of the sector, plus the yellow which is of the triangle, and the green area we see is 660 over 7 plus of the triangle is 36 root 3. So the entire area is 660 over 7 plus 36 root 3 centimeter square. Bottom part of the sum was, this angle was 60, hence this angle on the other side will be 300, and that is why we were able to find the area of that sector, because the theta was 300. From each corner of a square of side 4 centimeters, a quadrant of a circle of radius 1 centimeter is cut out. Also a circle of diameter 2 centimeters is cut out. So here we have a square, and from the square these quadrants have been cut out. This is a quadrant, quarter of a circle. This 4 quadrants have been cut out. So we need to subtract it from the square, these 4 quadrants. Plus this center, this circle also has been cut out. Then we have to find the area of the remaining portion. In step 1, we need to find area of square, and that is ABCD. And area of square, you know, is side into side. The side in this case is 4 centimeters. So area of the square will be 4 into 4, which is 16 centimeters square. So this is area of square. Then we need to subtract the areas that have been cut off. So we've got to subtract this area, 1 quadrant, plus the second quadrant, 2. This has to be subtracted. Third quadrant and fourth quadrant. These 4 quadrants have to be cut out, so they have to be subtracted. So in the second step, we have to find area of 4 quadrant plus we need to subtract also area of this circle. Now area for 4 quadrants will be 4 into area of a quadrant. Quadrant is quarter of a circle. That means pi r square, area of the circle, divided by 4 will be the area of the quadrant, plus the circle. Circle will be pi r square. Now here we cut 4, so what remains is pi r square plus pi r square. Pi r square plus pi r square is 2 pi r square. So 2 into 22 by 7, and the r is given to us. The diameter is 1 centimeter. The diameter is 2 centimeters. So the radius is 1 centimeter. So this is 1 square. So the green area will be 44 by 7. So the area of the remaining portion, so this is 44 centimeter square. So area of shaded region will be area of the square minus this area that is cut out, which is this area. So that is area of square minus the 4 quadrant plus circle. Area of square we saw was 16 square minus green area was 44 by 7, and when you work this out you will get the answer as 68 by 7 centimeter square. So this is area of the shaded region. (68 by 7 centimeter square. So basically in this sum what we did is we found the area of the square, and from this area of the square we subtracted those green areas, and what was left is this area of this shade, this blue area, after we subtract this area.